In today's video guys, we are going to make another conversion from decimal to octal. So our previous video we make a program that we can convert decimal to binary. Now I will share to you how to make a program that can convert decimal to octal. So let's start. So we have decimal 10 and this 10 is our base number. It's the representation that our value is decimal. So in this method is we are going to get first our decimal, or we are just going to convert it first to binary. The binary of decimal 10 is 1010 and the base number of binary is 2. After the binary is that we are going to get the octal. So in getting the octal is, as you can see, we are just basing our reference to binary. So what we are going to do in this method is we're just going to split our binary into 3 bits of value. So we have 0, 1, 0. So let's start to right to the left. 0, 1, 0. Put it here. 0, 1, 0. So another 1. So let's just assume that we have 2 0 here. 1 0 and 0. On the top of this bits value is our bits of binary numbers. We have 4, 2 and 1 for the first 3 bits of binary and another 4, 2 and 1 for the second bits. You can see we're just ignoring all the 0 value. So we're just looking for whatever there is 1 value. So here we have 1 and here we have 1. On the top of this value we have 1 and 2. So we're just bringing them down, 1 and 2. And this 1 and 2 is our octal. So it is 12. The second method is that we are getting the octal of this decimal 10 by the quotient and remainder. Octal is base 8, so what we are going to do is divide our decimal into 8. So in this first line, so we have 10 divided by 8, so whatever the quotient, that is 1, and the remainder of this expression, so we have 2. Next line is, so you can see our decimal now has a value of whatever the value of the quotient. So we are going to divide our quotient now by 8. As you can see, 1 divided by 8, that will be 0, and the remainder is 1. So we are just stopping this line because our quotient now reached the value of 0. And then from this remainder, we have the value of 2 and 1. So we start in the bottom to top. So we have 1 and 2. That will be our octal. So if we are going to construct a C program out from this method, we're just using this method because it is a lot easier. As you can see, we notice that we stop by dividing if our quotient reach a value of 0. And then the second one is that our decimal value is not constant, meaning it is changing every process. So initial value we have 10, then the second line it's not 10 but whatever the value of quotient. So overall we can construct a program. We have piece of code here. We are using while loop and we have condition here. If this condition is true, then perform this statement. Let's check if we can get the octal of our decimal 10. So in here we have while the initial value of our decimal is 10. You can see 10 is not equal to 0. That is true. So proceed. We have variable remainder to get the remainder, of course. So our remainder in this line is we have 2. As you can see, decimal divided by 8, we have remainder 2. This line here is to get the quotient. So we have 1, and this one will store to decimal. As you can see, our decimal will now change here. So the last line we are going to print the value of our remainder. So our remainder is 2, so it will now print in the output 2, as you can see. And now, since our decimal value is now 1, so it will change. It will not become 10. So we are going to put 1, and then it attempts to loop. It checks the condition. If our decimal is not equal to 0, we have decimal 1. 1 is not equal to 0, so again, true, perform the statement. So to get the remainder, we're going to divide the value of decimal to 8. So decimal divided by 8, we have that will be 0, and our remainder is 1. It will now store the remainder. So we have decimal divided by 8. So 1 divided by 8, that will be 0. And print whatever the value of our remainder. So our remainder is 1. So it will now print 1. Since our decimal now is equal to 0, it will now again change the value. So it attempts to loop. So you can see it checks the condition here if our decimal is not equal to 0. Since our decimal now is 0, so it is false and not perform this statement. So we have final output, but as you can see, we cannot print the value of 12. Instead, it print 2 and 1. So why is that happening? It's because our program starts printing from top to bottom. So as you can see, we have 2, 1. So what we're going to do is we're going to reverse our output. As you can see, we have 2 and 1. So instead, we are making a program that reverses this output. So 2, 1, that will be 1 and 2. So next is we have here, as you can see, we supplied our code from the previous, and we make use of what? An array. And then we declare another variable that would be index is equal to 0. We're going to simulate this program. As you can see, we have remainder. Since our decimal is 10, we have given 10, and the remainder of 10 divided by 8, that will be 2, and the quotient is 1. So this one will store to decimal variable. And then here, we are going to store our remainder in the elements ever the value of our index. So we have index 0, meaning in index 0, we are going to store the value of our remainder. So our remainder is 2. As you can see, it will store to this blocks. So this is our data. And then we increment our index by 1. So our index is 0, so plus 1, that will be 1. Since our decimal change, you can see we have decimal equals to 1. So our decimal now is not equal to 10. Then it loops again, our decimal is 1. You can see it just checks the condition. So you know it's 1 is not equal to 0, so that is true. And then our remainder will become 1. So you can see decimal divided by 8 is 0, and the remainder is 1. So the quotient of decimal divided by 8 will be 0. Here in this line, our index, since our index is 1, so meaning we are going to assign or store the value of our remainder in elements whatever the value index. Our index is 1, so meaning our remainder is stored in this index. As you can see, we're assigning the value of remainder in the index 1. Increment the value of our index, meaning our index is 1, so plus 1, that will be 2. So take note here, we have decimal equals to 0, we'll attempt to loop. As you can see, our decimal is 0 and it will become false. So overall, we have this data. So we have 2 and 1 in our array. What we are going to do next is we are going to print this 2 value here reverse. So instead we are going to print 2 1, we are going to print it 1 and 2. So to do that, we are going to use another loop to be for loop and print the elements. So we initialize I here by index minus 1. Our index is 2. As you can see, 2 minus 1, that will be 1. So we have condition is our 1 is greater than or equal to 0, then print, and after printing, decrement the value of I by 1. So if we are going to print the index I, our I is 1, as you can see 2 minus 1, that would be 1, meaning we are going to print this value in our index 1. So in our output, it will print 1. Then it loops again, decrementing our I by 1. So 1 minus 1, that would be 0. It checks the condition. 0 is equal to 0, then perform again. The value of our I now is equals to 0. We are going to print the element whatever the value of our index. So our index is 0, meaning this 2 will be print next. So now we have output 1 and 2. So that will be read as 12. As you can see, it will not loop again because 0 minus 1 would be negative. So this will become false. So we have final output. We have decimal 10 converted to octal 12. So now I will now make the program. Our program works perfectly and we can convert any decimal value to octal. I hope this video helps. Please consider to like and share this to your friends. Thanks.